Okay, so I'm going to do just a brief setup for friction free body diagrams. Okay, so if I have a system that's kind of like this, okay, and maybe I'm going to push this wedge in to raise this block up. So if I'm going to push the wedge in this way, then I have to recognize that friction is acting equal and opposite, which means here it's acting equal and opposite. And if this is going up, friction is going down. So I always start with that force P, because I'm either pushing, so my friction is going to the left, or I could be pulling, and then my friction will be going to the right. And then it's easy then to see as we move up where we have that connection, that interface, the friction is equal and opposite on the top piece. Okay, so how do I know what angles I'm looking at? So I'm going to draw this ginormous, and I would recommend that you guys draw this ginormous too when you're making your free body diagrams and you're first learning how to do this. Okay, and so then way down here I have this wedge, and it has the exact same slope of where it's entering. And you could note that this could actually have an angle on the bottom, like maybe it's like a triangular shaped wedge that we're pushing in. But for ease, I'm just going to do it like this. So we have the weight of A, okay? And then we have the weight, oh, you guys can't see, of B. And we're just going to call this one, we're going to push in. So I have P going in, which maybe I don't know. Or maybe I want to know, and I want to back calculate what can the weight of A be. So I should be able to work these forwards and backwards. So I'm going to start down here, and I'm going to have the force of friction, which is going to be, we're going to call this B, okay, normal of B. And I have the normal of B. And the normal force, normal is always perpendicular, and friction is always parallel, okay? They don't just go up and down in the X and Y, it's perpendicular and parallel. So now I need to draw my friction. I'm going to draw it kind of big so we can kind of see what's going on here. And I have the force of friction here at my AB interface, and that's going to equal the mu, my static coefficient of friction, and that normal force that's coming down from A, okay, which means B is pushing back up on it. And I know that I have that normal force that's going to be acting perpendicular to my cross section. So that's the normal force of A and B. And the forces acting up here on A are equal and opposite. So if the friction down here on B is going to the left, then I know that the friction over here on the top piece is going to the right. And that's still friction AB, which equals mu AB, normal AB. Okay. And I have a normal force that's acting, which is that normal force. Okay, so A is pushing down on B, and B is pushing back up on A. And then we could also have a normal force here, and I'm just going to call this A. Okay, and or it could be on this side. It doesn't matter. It could be somewhere on the side. And if I'm trying to push the wedge in, okay, let me get this up and then try to refocus. Okay. So if I'm trying to push the wedge in, that means this block is going to be going up. So our resisting friction is coming down. And whoops, that's our friction A, which is going to be mu at A, normal force at A. So we need to make sure that we start here so we know which direction our friction's going, and then continue friction up the system. And then we need to remember that that force of friction that we have is really the coefficient, the static coefficient of friction, times the normal force that's at that same plane. And so this way, we don't have 1, 2 unknowns. We really just have one unknown, okay? Same with up here. So how do I figure out what angle it is? Well, if I look at this, and I'm just going to kind of pencil this in and then go with different colors. If this is theta, okay? So this block is cut theta, okay? Then I know that the friction is parallel, so I know that my block is cut theta, same theta. So if I go with a different color, so let's go with green for our friction, okay? So my friction is going in this direction on the top block, and it's at this angle theta. Then I can look at this, and if I'm in the XY, then my Y is having to come down, and my X is having to go over, okay? And so now I can see when I want to take this frictional force back into my regular XY component system, I can come over here and look across. Let me find my eraser. I always write places and then need to readjust. So let's take that off. So when I look at this, okay, so is sine. So the Y component is going to be mu AB in AB sine theta. So adjacent, the X component then of my friction is mu AB in AB cosine theta. And so we've got our X and our Y components. And I know it's negative and it's negative. Okay? So now let's look at the normal force, and we'll do it in a different color. So if this is my normal force that's pushing up, okay, it's pushing up like that, then I also can figure out that I can either look here and call a theta, or I can look here and call the theta. So we're going to call the theta right here at the bottom. So my X component goes up, my Y component goes up and my X component goes over, and we're traveling by theta. So when I want the X component of my normal force, it's going to be NAB, so sine theta, and we can see that the Y component is NAB cosine theta, so okay? And now we have the normal and the frictional force that are not in our traditional XY plane. They are now back into our XY plane. And so if I know that the X component of my normal force is NAB sine theta, then when I come down here, okay, it's going to be the same holds true. Here's my theta. If I look at the Y component, so NAB cosine theta, NAB sine theta. And when I go back and look at, okay, again, I can either draw it this way as my theta, or I could draw it this way. It doesn't matter, theta. It doesn't matter which way I draw it. I'm heading back towards the left. So I can kind of look at this, and I know that I'm having to go up positive. See, before I was going negative, and then I have to go to the left, whereas before I went to the right. So this is going to be mu AB NAB, so sine theta, the X component mu AB NAB, so cosine theta. So I really think it will be super, super helpful for y'all when you're figuring out how to draw these free body diagrams, is to draw maybe one free body diagram on a giant piece of paper, because then it's easy to sit down here and break up into the X and Y components what you're working with. Sometimes maybe you have a triangular wedge or something. Sometimes it's easier to just go ahead and shift that XY, and maybe it would have been more simple to make our XY in this direction. And if we had done that, our normal and frictional forces would have remained the entire magnitude, but our weight and our normal force over here and our frictional force over here, we would have to change by whatever angle theta that we went from x-axis to our new x-axis. Okay, so I hope that's helpful. start with the load P. If we're pushing this way, friction is acting opposite, okay? If we're pulling, friction is acting opposite, and then you can move up to the wedge above it. When I sum my forces here, we could do that really quick. We could sum forces in the y direction equals 0. I'm going to start at the top and come all the way around. So I can see that I have a negative weight of A minus, I have this frictional force of A, which is mu A in A. I can look at this frictional force and I can see, oh, we are going down. So I have negative mu AB in A B cosine theta. Oh, sorry. Down sine theta. I even have it written out and I just can't follow my own directions. And then when I'm looking here, we're going up. So plus in A B cosine theta. And you can see that the friction is sine and the normal force is cosine. Those are always going to be opposite because my friction and my normal are perpendicular to each other. So I really hope this helps. I would say sit down, work through this with me, draw it out yourself, draw your free body diagrams ginormous so that you can see these forces in between, and then it's easier to see those X and Y components and label them. Okay, let me know if you have any questions.